Hello students, today we are discussing electric potential due to an electric dipole. Before learning this, we should know what is electric dipole. So in the previous standard we learned what is electric dipole, isn't it? As we know, the dipole or electric dipole is nothing but when the two charges are taken at finite distance. So let us consider this is plus q charge and this is minus q charge. They are separated by each other with the distance, the finite distance we can say that is 2L. Then this is known as electric dipole. Now let us consider this is the midpoint. O is the midpoint. From this to q charge plus q charge, the distance must be L because this total distance is 2L, so this must be L. Okay, from center it will divide this dipole, then this much length is L and this much length is L. So electric dipole is the combination of the dissimilar charges, and these dissimilar charges are separated by some finite distance. Now when we take the electric dipole, then we know there is a dipole moment, electric dipole moment, and it is always denoted from negative to positive charge, and it is denoted by letter P. And this is the vector quantity. It is always directed from negative charge to positive charge, negative charge to positive charge. Okay, what is electric dipole moment? It is denoted by letter P, and that is nothing but one charge, magnitude of one charge into the distance between the two charges, that is 2L. Are you getting? So if you see the magnitude of this P, that is always Q into 2L, or you can write here QL, 2QL, that is equals to P. So little bit about electric dipole we understood. Now we will see if the electric dipole is taken, then what is the electric potential at any point near to it. Okay, in the previous lecture we saw electric potential due to a point charge. Similarly here, now we are finding electric potential due to an electric dipole. So let us consider now here. Now this was for our understanding. We'll keep it aside here. Now we'll consider here the diagram. Again, the dipole we are considering. So it is, this is the dipole where plus q and minus q, two charges are taken and they are separated by some distance 2L. Okay, so 2L is the distance between them, and so here separately we can write this distance as L and L. Okay, now let us consider somewhere here this point is situated, and let us consider this point is C. Now even though on the board it is we feel that this point is very near and this distance is equals to this distance, but it is not, because this distance 2L is very small. Okay, we are considering charge and this distance is very small distance. L is very small. Okay, 2L is again small distance compared to this distance. Okay, now we are considering, let us consider a straight line. So here I can say this is R distance. The C point is somewhere at r distance from the dipole or center of the dipole, we can say. Now, there is a potential due to this dipole at this point, isn't it? But how will get that potential? That is considered as V, suppose. But this V is the effect of the potential due to the charge Q plus Q and due to the charge minus Q. So let us consider here plus Q plus V is the potential, or plus V1 we can say. V1, okay, not plus V1. V1 will take for our understanding. V1 is the potential at point or due to the plus Q charge. And let us consider here V2 is the potential due to minus Q charge. Okay, so what will be V here? This V is the potential at point C due to the dipole, due to the electric dipole. So the effect of the potential here will be due to the positive charge as well as due to the negative charge. So the potential due to the positive charge will be V1 plus the potential due to the negative charge is V2. So whatever potential is there at point C, it is due to both the charges here. So we can say the potential at this point is equals to V, and that is nothing but the sum of two potential due to these plus Q and minus Q charge respectively. Are you getting this? Now let us consider here, we have seen here this C point is at distance r from the center of the dipole. Now let us consider here again this distance, and this distance is we are considering, let us consider with this different color so that we can remember this. So this is suppose r1, and let us consider this distance, and that is r2. Now we can clearly see here the charge Q plus Q is there, and C point, there is a distance between C and plus Q charge is r1, and here there is a distance between C point and minus Q charge is r2. Okay, so after understanding the diagram, we can see the electric potential due to an electric dipole over there. So as we know, in general, the potential we will write in general, we can write potential V is equals to, what will write? The potential is 1 upon 4 pi epsilon 0 if the dipole is kept in vacuum or air. We can take it as epsilon 0, and that is equals to Q, that particular charge, and divided by the distance between them. So this is the general general equation we got for the potential. Okay, this is our equation number 1. Okay, now let us consider what is V1 and V2, because we need to find here V is equals to. Okay, so what you will write? V is equals to, V1 is equals to, so I'll write here V1 is equals to, V1 is equals to 1 upon 4 pi epsilon 0, all the things are similar. Here V1 potential is due to which charge? Positive charge. So we are writing here positive charge. We are taking positive charge here. And what is the distance between that positive charge and that point C? That is R1. So we will write here R1. Are you getting? So V1 is the potential due to the positive charge, and we can write it as 1 upon 4 pi epsilon 0 q upon r1. Let us consider this equation as second equation. Similarly here we will write the next equation, that is V for V2. Okay, so V2 is due to negative charge. So what is difference in this equation now? How to write that equation then? 1 upon 4 pi epsilon 0 minus q now it is, isn't it? Minus q, and divided by, what is the distance between them? That is R2. Okay, so this will be our third equation. Okay, but what is V actually? V is equals to V1 plus V2. So now we'll write that formula as V, and V is equals to V1 plus V2. Now we will get the value of V1 and V2 from equation number 2 and 3. That we will write here. Now I'll write this V is equals to, V1 is 1 upon 4 pi epsilon 0. This in square bracket I'll write the V1's value, and that is Q, positive Q as it is, without sign I'll write. So R1. Okay, this is the equation for V1, and plus sign as it is I'll put from the formula, and I'll write here 1 upon V2's value, 1 upon 4 pi epsilon 0. What is this? Minus Q. Now we have to mention this minus sign here, and R2. Good. Now we can add this. When we are adding, we can take the common things outside the bracket. So I'll take, I think Q is common, so I'll take Q common here. Then 4 pi epsilon 0 is common thing, I'll take here out of the bracket. And what is remaining, that I'll put here. So everything is taken out, so only R1 is remained. So I'll put here R1, and the minus sign is there, so that I should mention now plus minus minus. So minus sign will be there, and only the 1 upon R2 will remain inside. So V is equals to, I am getting this equation, that is Q upon 4 pi epsilon 0 in bracket 1 upon R1 minus 1 upon R2. That again we simplify this equation as Q upon 4 pi epsilon 0. Okay, and I can write this after taking LCM, R1 R2. For LCM we are taking the product of these two, and so here I'll get R2 minus R1. Okay, this I can write. Okay, and this is my fourth equation. This is fourth equation. Okay, then we'll go next. We have to remember this equation now. So we'll remember this equation and we'll go ahead. So here I'll write V is equals to 1 upon 4 pi epsilon 0, and what is the next thing? That is R2 minus R1 upon R1 R2. R2 minus R1 upon R1 R2. That will write R1 R1 R2. Okay, in bracket I'll write here. Okay, fine. Now consider this diagram here. Let us consider this. Here I'll write now, suppose this diagram again I'll put here. So I'll show here you this is the positive charge and this is the negative charge. Okay, so this is called as electric dipole, and somewhere here the C point is where we are determining the potential at that point C. So this is our R1, this is R, and this is R1. Okay, R1, this is R, and this is R2. R2, this is R. Okay, now if we consider this length 2L is very very small. Suppose I am taking this as compared to this R. So let us consider here this is the point and small distance I am taking as where these two uh, charges are kept. So if we compare here and if we will take all these three lines R1, R2 and R, so let us consider a straight line from here and one more line which is from the center. So if you will consider these three lines, these are approximately equal, you can see now. Are you getting? If you make this length very very small or near to each other, if these two charges are very near to each other, then we can say these three lines or these three distances are equal. So from this we can say, because these charges are very small, and so the dipole, electrical dipole, is very small in size compared to this distance. So here we can say R is very very large than the L. Then we can say R1 is equals to R2, and that is equals to R. Are you getting? So they becomes very near to each other, and we can say they are approximately equal to R. They are approximately equal to R. So if R1 is equals to R2, then we can write here R1 R2, that is equals to R into R square. But now we are not taking this as 0. Why? Because let us consider here, suppose we are considering here 3 point in mathematical numerical example I am giving to understand it. 3.263 is the one number, and another number is 3.2632. If we compare these two numbers, then we can say these are approximately equal number. So if we multiply, you can take the nearest value of this and you will say this is equals to this, and you can take this multiplication. For multiplication you can take it is approximately equal to 2.6. Okay, and multiply it. But if you want to subtract it, then it will not be 0. If you are subtracting this number, it will be something 0.00 here 0 something like okay, something like this, and this will be the number, but it will not be 0. Suppose this is 2, so it will be 0. So 2 we are taking. So it is 0.0008, but it is not 0. Some subtract, when while doing the subtraction, you will get some number. So whenever we are approximately taking equal R and R1 as approximately equal, then while doing the subtraction we are not taking the value as 0 here. Okay, so for your understanding it is. Now so what we'll do next, as we know these are equal, so we'll write here now, just a minute. So can rub and I'll write the correct here. Okay, so what I told just now, the R1 and R2 are approximately equal when the length of the L or dipole is very small as compared to R. Then we can say here R1 is equals to R2 and that is equals to R. So that time we will write here V is equals to 1 upon 4 pi epsilon 0. I'll write, and this is R2 minus R1 approximately, that I'll put as it is, and only here I can write R square, because I consider here R1 is equals to R and R2 is equals to R, then R square it will be. Now here this is the equation that I have to remember now. This is equation number, say it is last equation was fourth, now it is fifth equation. Okay, so I'll write here fifth equation number 5. Okay, fine. Then now I want to find this equation. Okay, I don't know what is the value of R2 and what is the value of R1. R2 minus R1 I am going to find. For that I am using the cosine rule. So now again I'll consider here the diagram so that I'm not going on the last page again, previous page again. So here this is the dipole, this is the distance between them, 2L is the distance. So this is the C point, here I am taking, this is R and this is R1, let us consider, and this is R2. So this angle I am considering as theta. As we know, the P is denoted by electric dipole moment is denoted by P, and it is directed from negative to positive charge. Okay, so by cosine rule we can write here now this I am going to find R1 is equals to. So R1 I can write R1 square is equals to. Okay, if you have to remember that if the angle is acute, then the sign will be negative. So here this is the R. Okay, this line is R. So R, and what is this line? This much distance is L. Here is also L. So now it is one triangle we are considering here. Which triangle we are considering? Here this is the triangle I am going to consider. Okay, in which this is angle theta. So in this triangle C and CQ, let us consider here O, CQO. In this triangle I can say one side of this triangle is R, okay, R square plus L square, okay, minus, now because this is acute angle, so minus R L cos theta. This is our equation number 5th. Let us consider it as 6th. Okay, similarly R2 I am going to find from the same geometry of the figure. So R2 square is equals to R square plus L square. Now this is the another triangle. Okay, which one it is? This is the another triangle I am considering. So where this angle is now 180 minus theta. Are you getting? This is theta, this is the central line. Okay, so here this angle becomes theta, so it will be now 180 minus theta. So it is more than 90. So that time we are going to consider this sign as plus sign. So if the angle is less than 90, we will consider minus sign. If the angle is more than 90, then we'll consider it positive. Okay, so you have to remember this only. So our mathematical expression you have learned in 10th standard, 11th standard. So r l cos theta. Okay, this is our seventh equation. Good. Now from this I'm subtracting this. What I want actually, I want to find r2 minus r1. So that I'm trying. So this, from these equation I can get this equation as r2 square minus r2 is first. So I'm taking r2 first. r2 minus r1 square, because these are square quantities, so as it is I'm taking. Then after I'll make it r2 minus r1. So here the first r2 is, now here this is the value, and that I'm substituting. So r2 plus l square plus rl cos theta, minus sign is there, that minus sign I'm writing. So everything here as it is, first I'll write, I'll not miss that step also. So r square l square minus r l cos theta. Okay, fine. Then I'll write here r2 plus r square plus l square plus 2 r l cos theta, r l cos theta, minus sign. Now this minus sign I am multiplying into this bracket with this minus sign. I will get here r minus r square minus l square. Now minus minus becomes here plus r l cos theta. Okay, then what is the simplification next? That r gets cancelled, l square gets cancelled, r square gets cancelled. Only the remaining thing is here rl cos theta and here rl cos theta. So sorry, it will be 2rl now. This is I should write here in formula. It will be r square l square minus 2rl cos theta. This should be there. Okay, everywhere it will be 2rl. So I missed that. Okay, so it will be now here 2rl becomes 4rl cos theta. Fine. And this is equals to r2 square minus r1 square. But what I need r2 minus r1. So I am expanding this equation. So we know a square minus a square minus b square is equals to, here in bracket, first bracket a plus b, and in second bracket a minus b, isn't it? Similarly here we are writing, here in first bracket I'll write r2 plus r1, and in second bracket I'll write r2 minus r1, and that is equals to 4rl cos theta. Okay, fine. But I need this quantity this side only and not this. So only this I am writing r2 minus r1, and that is equals to 4rl cos theta as it is. But this quantity, if I am shifting this side, so it will be divided by r2 plus r1. Okay, so now from this again I'll go here and I'll see what should I write here. See, in this previous r2 minus r1, that is equals to 4rl cos theta divided by r2 plus r1. Same thing I'll repeat over here. So r2 minus r1 is equals to 4rl cos theta divided by r2 plus r1. Okay, fine. Now as we know, we consider in the first slide that r2 is equals to r1 is equals to approximately equals to r. Okay, so here I'll write r2 minus r1, because already I told you we are not taking it as 0. So 4rl cos theta divided by, instead of this we can take it as 2r. Okay, this is r plus r, that is 2r. So this will be 2 and this r gets cancelled. So we will get here r2 minus r1, that is equals to 2l cos theta. Okay, so this equation we got, or this value of r2 minus r1 I am getting here, that I can put into this equation. What is that equation? V is equals to 1 upon 4 pi epsilon 0. In this equation, this substitution I can do from this equation number 8. Okay, so I'll write here again. This is equation number 8. Let us consider. So putting the value, or we can say substituting the value of r2 minus r1 from equation 8 to, which is that equation that we considered, that is fifth equation, in equation to equation 5 we'll get now. So the equation number 5 will write now again, v is equals to 1 upon 4 pi epsilon 0. Okay, that I'll write v is equals to 1 upon 4 pi epsilon 0. So this here r2 minus r1 is there, and divided by r square will be there. Okay, see here again r square. Okay, so this value of r2 minus r1, that we are putting from equation number 8, and that is 2l cos theta. Oh yeah, here it is q, it should be q, 1 upon something is lost here, 1 upon q nikala tha constant, that we will put here. So it will be here now q, that we missed. So here now I'll write q upon 4 pi epsilon 0, and this value. After putting this value, v is equals to, now let us consider here in this equation I saw, I told you that what is the p is the electric dipole moment, and the value of electric dipole moment is 2ql, that you have to remember, 2ql. Now see here, I'm collecting this together, so it will be q into 2l, okay, divided by 4 pi epsilon 0, and the remaining thing I am writing here, that is cos theta upon r square. So what is this? This is nothing but, this whole thing is nothing but q by 2l is nothing but p. So let us write here p. So v is equals to now p into cos theta upon 4 pi epsilon 0 into r square. So this is the potential due to the electric dipole when the point is at C, at distance r, and that whatever potential is there, that is due to the each and every charge in the dipole, that is positive and negative. And so the total potential due to the dipole, we can say, that is P cos theta upon 4 pi epsilon 0 r square. This is the magnitude of the potential. Okay, let us consider this is equation number 9. But if I want to write it in the vector form, so how to write now? So let us consider here. So let us say here V is equals to, again I'm same quantity I'm writing, V is equals to P cos theta upon 4 pi epsilon 0, P cos theta upon 4 pi epsilon 0 r, 4 pi epsilon 0 r square. Okay, this magnitude I am writing. Now what is this value? How to find this value? What is P cos theta? It must be the vector dot product of the unit vector and the P vector, isn't it? So which is that? Suppose again for this consideration, again I'm using here the diagram. So let us consider here it is positive charge, negative charge, and so this becomes a dipole. This is the center of the dipole, and this is the two distances from the charge, positive charge and negative charge, up to that point C. So here we consider theta. Now let us consider the electric dipole moment, that is P. Okay, it is directed in this direction. Okay, so let us consider it is from this to this. Okay, so this is small p, we can show. Now this is r. Okay, this is the distance r. Okay, in this direction, suppose I am taking a unit vector, and that unit vector is denoted by r cap. So it is in this direction. Are you getting? It is in the direction of the distance, so it will be here in this direction. So r cap. So if I'll take this dot product of these two, then vector p, I'll write vector p into the unit vector r I'm taking. So what will be the dot product of these two? If any vector I am taking A and any vector B I am taking, if the dot product of these two is taken, then it is A magnitude of first vector into magnitude of second vector into cosine angle between them, isn't it? So see, similarly here also we can find here P is the magnitude of this P, and unit vector is taken, r is unit vector, so what is the magnitude of it? It is 1, and cos angle between them, and what is the angle? Theta. So cosine of theta will write. So here I can write P1, no need to write, so P cos theta I can write here. So whatever this value is nothing but the dot product of these two vectors. Are you getting? So I can write now here, instead of this I can write in vector form. If I want to write this potential is scalar quantity, but if it is in the vector form I want to denote, then this I'll denote as, so what is P cos theta? P cos theta is nothing but this. So I'll write here vector P into r cap divided by 4 pi epsilon 0 r square. So this is the scalar form of the vector. And also it is also denoted as, we can write here, v is equals to what is r cap. R cap is nothing but vector r divided by the distance r, isn't it? So instead of this we can write this also. So p vector p into, I'll write here r vector, and this r I'll write down, so it will be 4 pi epsilon 0, okay, r square. This whole thing I am writing here, and इसके बजाय हम लिखेंगे r, okay. So this will be now v is equals to p, that is vector p dot, now r, the vector r I am writing, and divided by, it will be 4 pi epsilon 0, this r into r square into r cube it will be, no. So this is the vector form of the potential. So if you want to write this in the form of scalar quantity, the potential will be this scalar quantity, or if you want to write it in vector form, you'll write it in vector form. This is the vector form, and this is the scalar form. These are two equations. Now let us consider how this vector is changing, or where the potential is more or less, how we'll find. The potential changes, means potential is varying over there, and how we'll get the variation over there, because it is a cos product. So cos theta, okay. So cos theta का वैल्यू कहाँ से कहाँ तक चेंज होता है, 1 to -1, correct. So maximum to minimum, where the potential is maximum and minimum, then how we'll get. So if we'll see here, let us consider this is the coordinate. Suppose here I am taking this theta in positive charge, towards positive charge I am taking, here minus q charge I am taking. So the p is directed here from negative to positive. The potential v is maximum here at this point, okay. So here in this range, because the potential is maximum, maximum, that is positive, and that is minus 1, isn't it, 1 2, or as you go here like this, and if you reach at this point here, it will be 0. Here to here it will be 0. Why? Because see now here, cos theta, if theta here in this case, if cos theta is there, and in this direction positive potential, then theta is equals to 0. Theta is equals to 0, isn't it? So cos theta becomes, cos 0 is 1, isn't it? So the maximum potential you are getting here. So as you go like this, from this to this position, you will get here theta is equals to 90. As theta is equals to 90, that time cos 90 becomes, cos 90 is 0. So at this moment here you will get v is equals to 0. But as you come here this side, then what will happen? To this position, if you are coming this to this, and you will reach at this point, that time theta is equals to 180. So it will be maximum, but negative maximum point will be there, okay. So cos theta becomes here -1. So minus potential you are getting here, -1. Okay, and if you'll go like this again, you'll reach to this point. Again, this is theta is equals to 90, and so here again v becomes 0. So at this position, potential will be 0. So up means y-axis, positive y-axis if you'll see, then on that also it is a 90 degree, theta is equals to 90 degree, and minus y-axis if you'll see that there is also theta is equals to 90 degree, and so cos theta becomes there, cos 90 is equals to 0. So the total potential becomes here 0. Are you getting? So here the potential is maximum towards the positive charge, and if the negative charge is there, potential is negative, but at this point the potential is 0. So it is all about the potential, electric potential due to the this electric dipole. Okay, so we will saw step by step, and this steps mathematical expressions are important. Before that you should know what is dipole, what is electric dipole moment, and then only you can solve this very well. So we'll stop here today, and we'll discuss next thing in the next lecture. Till that time, have a nice day, stay safe. Thank you.